Okay, so going through this lab, essentially what we're going to do is we're going to code something in Python. Most of my videos are about programming stuff in Matlab, but if you are a reasonable Matlab programmer, going to Python isn't that bad. It'll be totally fine, you'll get it. So I just wanted to take a little bit of time to show you around Python. So what we're using here is Google Colab. It's a way that you can run Python on just the internet and not have to install anything on your computer, so it's really nice. You know, we can do pretty print and then we can do actual code, so I can just like add a code snippet or a text snippet depending on what I want to do. Okay, but really what we want to look at is how to do something cool in Python. So I'm going to have you guys do here is the Mandelbrot set. So there's a fantastic video by Jonathan Coulton, or a song by Jonathan Coulton you totally have to listen to because it's fantastic, about the Mandelbrot set. So if you've ever seen the Mandelbrot set, I can't spell, Mandelbrot set picture, it's this picture. So if you've ever seen something like this, that's the Mandelbrot set, and these are just people doing cool things with the Mandelbrot set. And the idea is the more you zoom in, there's just more and more and more fractals. I mean, it's just the more you zoom in, the more complexity there is. No matter how much you zoom in, there's always infinitely more complexity. So we're going to make a Mandelbrot set picture in Google Colab, but we're going to assume that you've only been mostly programming in Matlab. Okay, so here are the basic rules to create a Mandelbrot set. You take a point in the complex plane, so that means it needs to be like a plus bi, and then you start with z equals 0, and you just keep reiterating over and over and over again. And if z stays what they call sufficiently small, then the point is in the Mandelbrot set. So these are just the lyrics to the song because it's awesome. So you do start with z equals 0. You have a complex number. You get to pick kind of how close you want that to be. So you could make the limit be 2. You can make the limit be 10. You can make it be 0.5. Now, in theory, you would run this an infinite number of times to make sure that it stays in the set for all of infinity, but usually we just do like 100 and then we go, okay, that's good enough. Now, as you're going into Python from Matlab, so Matlab is space insensitive, so I can have my entire for loop left aligned. It does not care. Python is space sensitive. So I'm going to give you an example. I'm just going to come down here and type. So if I say, you know, this isn't even correct Python talk, but if I do this, something like that, so this is not how Python thinks. This would run just fine in Matlab, but the way that Python handles things like for loops is it'll start with the for loop, which is, again, not written like that. I'm just trying to make an analogy. Anything inside the for loop is indented under the for loop, and then anything, and I don't put end, so I just indent, and then whenever it gets to the end of the indentation, it's no, it's done. And then if I said y equals 3, the x equals 3 would happen 5 times, and the y equals 3 would happen once. So if you do this, not that it would matter specifically for this, but there we go. So I equals 1, 2, 3, 4, 5, y equals 3. If you just ran this, you would probably get an error. So you can just hit the tab button, or you can hit space twice. But anything that happens here all needs to be at the, and again, this is not good Python, but it all needs to be at the same indentation. So this is like the key part of Python. A key part of Python, if you're coming from other programming languages, is that the orientation of your code matters. So if you have this, or if you have this, it's going to get mad. So everything that is within, say, a for loop needs to be indented. Anything in a function needs to be indented, because there's no end. It's just like everything that's at this indentation is the same priority. Okay, so there's that. Now, another thing that's really different between Python and Matlab is powers. So Matlab can just say x squared, x to the 2, which makes a lot of sense. But Python uses this old Fortran stuff from the 1950s. Because back in the 1950s, all you could use was A through Z and 1 through 9 or 0 through 9. So you didn't have access to like the caret. So they did double, double, star, star for a power. And then eventually they created, whenever they eventually got the caret, they said, well, that's exclusive OR. So, you know, exclusive OR true and true is false, because only one can be true, not both. So exclusive OR false false is false. Exclusive OR true false or false true is true. So in Python, they kept the old school Fortran stuff where that means exclusive OR, and the X choop choop is the power. I would say, now obviously there's a lot more things that are different MATLAB to Python. I'm just trying to get you to the ones that are going to be the most annoying right away. Also, MATLAB is cool with using I or J for the square root of -1, but Python you can only use J. And you have to specifically say 1J or 2J, because otherwise J by itself is just considered a variable. It makes me sad. Okay, now this is another one that can kind of get you, is that MATLAB will index at 1 and we use parentheses. So if I'm going to a list, it's A parentheses 1. Python indexes at 0 and uses square brackets. So the first element of a list A is A square bracket 0. This is kind of like the difference if you've ever traveled outside the United States. They start, the ground floor is floor 0, and then they go 0 floor, first floor. Like the first floor is the first floor up, and the second floor is the third floor up. Basically, they index at 0. So whenever you go overseas, a lot of countries index their elevators at 0. So 0 is the ground floor, and then 1 is the first floor up. So whatever floor you're on, if they say you're on the second floor, that means you need to go up 2 sets of stairs to get to your room. But MATLAB indexes at 1, so the first element is literally the first element. The second element is the second element. So again, this is just a choice. And this is a big thing with programmers, that you're either like super into one or super into the other, and everyone else is wrong. And that's the whole fun of being in academia, and knowing things is gatekeeping apparently. But so the idea is, if you're doing a for loop, like in MATLAB, we might go from 1 to n. In Python, you'll usually go from 0 to n minus 1. So it'll stop before you hit n. C also does this. C++ indexes at 0, that kind of thing. Okay, now for setting up sequences, to get the numbers 1 through 5. In MATLAB, we can just say 1 to 5, but in Python, we would need to say range 5, and then we'll get 0 to 4. Because remember, it indexes at 0. So it still has 5 elements, it just starts at 0 and goes to 4. And this is just something you can't fight City Hall. You just gotta love it and be fine with it, and that's okay, and it'll make you a better programmer and all that good stuff. Okay, so a couple of other things. In MATLAB, you've installed it on your computer, you've activated it for your web version. All the functions are immediately available. There's a lot of basic functions even included in the standard installation: square roots, sine, cosine, blah, 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 blah. Okay. Python is not like that. It is minimalist, so it only includes the functions that it super duper duper needs to have in order to run faster, in theory. So in Python, whenever you're just working out of the basic version of Python, you only have a certain number of functions that are available to you. So some basic math functions like absolute value, round, power, max, min. You can do data types, int, float, etc. You can do, equals, plus equals. So if you did any kind of C or C++ with plus equals, you can do that. You can do and or not, comparison, if, else, blah, 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 blah. Now, things you might expect to be built in but aren't. Plot. Plot is not built in. If you want to plot, you have to explicitly say, I would like to import this matplotlib.pyplot as plot. So basically what you're saying is, I need to import a library that explicitly has a plotting function in it, and I'm going to I'm going to type less, so instead of typing that out every time, I'm going to call it PLT. So if you kind of want to see what's in pyplot, matplot library, It says it basically provides a MATLAB-like interface for plotting. So Matplotlib is pretty fantastic. Everything that you could use in MATLAB, Matplotlib, lib is library, is generally what you're going to be, what you can do. So this is a pretty straightforward. So instead of just saying X label, though, you have to say it's plt.x label. So if you remember doing things in App Designer, where you had to say app.variable1, app.variable2, it's the same thing here. You have to do plt.x label, plt.y label, plt.title, and stuff like that. So Matplotlib is the thing that has the plotting tool in it. NumPy, I don't know how to say it. If you want to see what's in NumPy, these are where you get a lot of your good math functions. So the absolute basics for beginners. Okay, we don't have to, well, I mean, we do have to import it, but this allows you to have arrays, like lists. So like MATLAB is automatically designed to have arrays. Python is not. So NumPy allows you to do all of the, oh, here's NumPy for MATLAB users. Look at me. So the basic type, even for scalars, is an array. And I think I've mentioned that MATLAB converts scalars to arrays. So if you say x equals 1, it actually says x is a 1 by 1 matrix that has a 1 in it. Anyway, but NumPy, this is how you set that up. And again, indexing at 0, there's all these kinds of things and blah, 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 blah. So a lot of the math that you're going to want to do, like sines and cosines and all that kind of stuff, is in NumPy. It doesn't actually tell you how to pronounce it. Okay, so a lot of these, like making an array, random, standard deviation, sine, cosine. I'm pretty sure sine, cosine are in there. I'm not 1,000% sure, but if you need it, you can. Let's see. Which Python library has sine, cosine, tangent? Oh, it's the math module. Well, there you go. So I would need to import the math module. So if I want to do math, math.sine, math.cosine, math.tangent. So the good news is when you try to do it and it doesn't work, then you Google it and figure out what you should have done in the first place. Okay. So hopefully this is enough just to get you realizing that there are going to be some things that are different. So whenever we start coding, you're not just like totally going crazy. But this should be enough to get us where we need to go for the purposes of today.